In this chapter, we're going to learn more about C#'s input and output methods. In other words, how to get data into our programs and more about how to get data out of our programs. We've already used console.writeLine quite a bit, but there's more to say about WriteLine and write, so we'll look at those later. We're going to start out in this lesson learning how to input strings and chars or characters into our program. So let's get started. We'll start out with strings. We're going to create a string variable name. Then we're going to prompt the user to enter their name, and then we're going to get that input using console.readLine. Readline reads everything the user types up to the enter key and stores that in the variable that we've put on the left-hand side. And then we can write out. So let's run this program. So if your name is Mary Smith, your name is Mary Smith. So you see what happened. I typed Mary Smith and hit the enter key. Mary Smith was stored in the variable name, which you have right here. And then we wrote it out. Your name is Mary Smith. So that's really quite simple. What you need to know is that readline reads your data in as a string. Now, you may not want to do a string. You may want to do a character or a char. So you want to enter a letter. So we're going to have to do that a little bit differently. First, let me comment out this code. I'm going to do that using the comment out command on the icon bar, like so. That comments out all my lines at once, saves me a little bit of typing. So I'm going to create a variable, char letter. I'm going to prompt the user to enter a letter, enter the letter, Y or N. And then we're going to write letter equals, and now here's where it gets a little tricky. You can't just write read, which is the command. We have to convert it from integer, which is what read stores the input as, into a char. So just like we did convert to int32 earlier to convert from double to integer, here we have to convert what read reads, which will be the integer value of letter, the ASCII value, into char and then store that in the variable. So then we can write out what they entered. You entered space and then the letter, and then we'll put a period again to be grammatical. Let's run that program. We'll do a Y. You entered Y. And that would work with any letter, of course. What we've seen in this lesson are two ways to read data into our program. Using console.readLine to read strings, that could be one word or a whole sentence, even more than that, but generally it's going to be limited to just a few words. We saw how to use read to enter char data. We just had to make sure that after we used console.read that we converted it to char using convert.toChar. So that wraps up this lesson on entering strings and character data. Now let's move on to the next lesson where we're going to learn how to enter numbers. In this lesson we're going to discuss how to input numbers into a C# program. You do that similarly to inputting strings using console.readLine. But once you've used console.readLine, you have to convert that input, which will be in string form, into the proper numeric form. Let's look at an example. We'll create three variables, num1, num2, and result, each of them integers. We'll prompt the user to enter a number. We'll get that number in with console.readLine, and then watch what happens. There'll be an error right here, because the compiler recognized that we cannot convert type string to int. So what we have to do is we have to wrap the console.readLine or package console.readLine inside a convert to int32, like that. Enter another number, be our next prompt, and then we'll type num2 equals convert. So notice I'm going to hit tab here, and that will select to int32, and then console.readLine, like so. Then we'll write result is equal to num1 plus num2 just to do something with the numbers. Doesn't really matter what. And then we'll display the result at the end. Now we're ready to run the program. So we'll type in a number 23,456 and 1 is 23,457. And that's all you have to know to do. You have to know that once you've gotten the input in with console.readLine, you have to convert it to the proper data type. And we could very easily change this from int to double. And all we have to do here in the input is change the conversion. So change both conversions from 2int 32 to 2int double, and now the program will work with floating point. So we'll type 3.14159 and 0.15 to get 3.29159. You might be tempted to try to use console.read, because if you were paying attention before, you remember that read reads in an integer, but what that integer is actually the ASCII value or an ASCII value. And console.read is very unreliable and just downright wrong to use when trying to input numbers. So when you're trying to input numbers into your program, use console.readline and then the proper convert function, to double, to int, 32, whatever the data type is you're trying to convert to. And that's all you need to know about inputting numbers. So let's move on to the next lesson where we talk a little more about working with console.write and console.writeline to output data from our programs. We've already seen how to output data to the console using console.write and console.writeline. So let's just go over the rules very quickly, then I'll show you one alternative means that we haven't looked at yet. The standard way to write output is either console write or console write line, depending on if you want to move the cursor to the beginning of the next line after the output or not. If you don't want to move the cursor, then you use console.write. If you do want to move the cursor to the next line, then you use console.writeline. So console.writeline or console.write, either one, can output strings, numbers, numeric expressions, and variables. Essentially, any expression that can be evaluated can be placed inside console writeline or console.write, either one. I'm not going to run this program because you know what will happen for each of these console.write lines. There is an alternative way to write data using console.write or console.writeline. Let me demonstrate how it works. We're going to say hello to Mary rather than hello world. So the way we would do it using the means we know so far is to use concatenation. But there's another way to do it where we don't have to concatenate the string variable. Is using what I'll call a placeholder. Let's see how that works. And then inside the string, we put a curly brace, a 0, then another closing curly brace, followed by the close quote, followed by the variable name. Now let's comment out everything but this line so we can see how it works. We also need a console read key so we can see what we've output. Now let's run this program. Hello, Mary. So this is an alternative to using concatenation. It works very well with longer strings. Let's create another variable. And here we want to write hello, Mary, and Mark. So what we'll do is we'll put another placeholder for 1 and then another variable, name 1, right after that. Now let's run this program. Hello, Mary, and Mark. If we didn't do it that way, we'd have to use string concatenation like this. Hello plus name plus and plus name 1. So as you can see, using the placeholders is quite a bit easier than having to use the concatenation. Either one works fine and either one is acceptable, but using the placeholder method is a little bit easier to type and you're less likely to make a mistake. So I would suggest using that technique when you have several variables that need to be displayed in the same string, like we have in this example. There's really not much more to say about console.write or console.writeline. I primarily wanted to show you the placeholder method in this lesson. So with that, we'll stop and move on to the exercise for this chapter where we're going to develop a form letter using the techniques we've learned for input and output. We're ready to work the exercise for this chapter, and what we're going to do is we're going to create a form letter that we can send to people who give us presents for, say, our birthday. So we're going to begin by creating some variables, including the name of the person who gives us the gift, present for the gift that they give us, your name for the person writing the letter, and then int age for the age of the person who's going to have a birthday. So we'll begin by prompting the user to enter the data for these variables. So we'll say, what is the name of the gift giver? That's the first prompt. And then we'll say name is equal to console read line. We'll prompt the user to enter the gift they got. And then another console read line. Then we'll prompt the user to enter their age on the birthday. And here we have to convert to int32 after we get from the console. And then finally we'll prompt them to enter their name. Your name equals console readline. Now we're ready to generate the letter. So the first thing we'll do is we'll write a blank line, put some space between our input and the output. Then we'll start out by writing dear, and then we'll use a placeholder here, comma, name. So dear whoever sent us the present, and then a blank line. Thank you for the, and then we'll use a placeholder for the present, like so. And then we'll start a new line. And we'll continue on. I can't believe. And then console write. We don't need a space here. I can't believe I'm already, and here we use concatenation. Age, years old, comma, but right line. It doesn't feel that much different than a space being, and then we'll use concatenation again. Age -1, and then a period, and we'll end the letter there. So we'll do console right line parentheses, console right line sincerely, and then a console right line for a space, your name. And there's our read key, so now we're ready to see if it works. We'll say it's Aunt Jean that gave us the gift. She gave us a sweater. We were 13, and our name is Bobby. Dear Aunt Jean, thank you for the sweater. I really like it. I can't believe I'm already 13 years old, but it doesn't feel that much different than being 12. Sincerely, Bobby. That exercise uses the skills we learned in working with input and output to both get input from the user, converting those numeric inputs that we need to convert from string to a numeric data type, and then using console write and console write line along with placeholders to display the output. So that wraps up this chapter, and now we're ready to move on to the next chapter where we talk about decision making, and we'll begin with the first lesson on relational operators. In this chapter, we're going to introduce the ability to make decisions in our programs, such as in a payroll program where you have to decide whether you're going to pay an employee overtime based on whether or not they've worked over 40 hours a week. Or in almost any program where a password is collected, does the person's password that they entered match what you have on file or stored for them as their password? Those are what we mean by decisions. And we make decisions using something called the if statement. But before we can begin learning about the if statement, we have to learn about conditional expressions, or what are called relational expressions. For example, if we have the variable hours worked, let's go ahead and set it to a value. We can write a relational expression to check to see if hours worked is greater than or equal to 40. This expression, hours worked greater than or equal to 40, will return either a true or false value. That's what the relational operators do. They return true or false. In this case, it's going to be true because we do have greater than or equal to. In a real payroll program, you would probably only pay overtime if the hours worked were greater than 40. So here's another example. Hours worked greater than 40. So let's take a look at the different relational operators. Let's start with a new example. We're just going to create two variables, number 1 and number 2. Assign them values. We're going to display the results of these relational expressions in a console write line statement. So for example, the first of these is number 1 greater than number 2. That's our first relational operator, the greater than sign. We actually aren't going to display these in this lesson. I'm just going to demonstrate how they work. The next is the less than sign for less than number 1 less than number 2. Then we have number 1 equal number 2. Notice that the equality operator is the double equal sign. That's because we've already taken up the single equal sign for assignment. So we have to use double equal to represent equality. So here we're saying number 1 equal number 2. And of course that's false because 12 is not equal to 133. Next we have greater than or equal to, which we saw earlier. Then we have less than or equal to. And then the last relational operator is not equal to. And that's exclamation equal sign. The exclamation mark is the not operator. But in this particular case, we're saying number 1 not equal to number 2. Now if we run this, we'll get a series of true false values. And we can compare these here. Number 1 greater than number 2 is false because 12 is not greater than 133. That means number 1 less than number 2 is going to be true. Number 1 equal to number 2 is false because, as we said before, 12 is not equal to 133. Number 1 greater than or equal to number 2 is false because number 1 is less than number 2. 12 is less than 133. Number 1 less than or equal to number 2 is true because number 1 is less than. And then finally, number 1 not equal to number 2 is true because 12 is indeed not equal to 133. So these are the relational operators: greater than, less than, equal to, greater than or equal to, less than or equal to, and not equal to. And we use those in what are called conditional or relational expressions to determine how two expressions compare. We can also combine relational expressions using what are called the logical operators, and we're going to look at those in the next lesson. In the last lesson, we looked at the relational operators and how to use them to form relational expressions. In this lesson, we're going to look at how to combine two or more relational expressions using what are called the logical operators. Let's begin by looking at what the logical operators are. There are two that we're going to discuss: the logical AND, which is written with two ampersands, and the logical OR, which is written with the double bar. Logical AND, when combined with two relational expressions, will return true if both relational expressions are true. So in other words, true and true equals true. If either one of the expressions is false, then the whole logical expression is false. So false and true equals false, true and false equals false, and false and false equals false. With the logical OR, only one of the two relational expressions has to be true. So we can have true and false equals true, false and true equals true, true and true equals true, and then false and false equals false. So just remember, with logical AND, both sub-expressions have to be true, and with logical OR, either one of the sub-expressions has to be true. Let's look at a couple of examples just to see how it looks in code. So what we're going to do is we're going to create a little password program. We're going to have a name or a username and a password, like so. Then we're going to have a Boolean variable flag that will be used to store the result of the logical operation. So we might write something like this: flag equals name equals John, and password equals let me in. Then we'll write out the value. Okay, we've left something out. Let's see, we left out a quote right there. There we go. Then we might want to write out the result. So we'll do a console write line flag. So let's run that program. And we'll see it returns true because indeed name is equal to John and password is equal to let me in. If we changed one of those, let's say by spelling the name John wrong, then the result of the logical operation will be false. So that's how the logical AND works. The logical OR we could use like this: name equals John with a capital J, or name equals John with a lowercase j. Now if we run that, it will be true because in this case both are true. We could misspell one of the Johns here, like so, and now it's false because we misspelled this John. So in this case, neither one of them are true, so the whole thing is false. Whereas when we wrote it like this, the expression was true because this John does indeed equal what we stored in the assignment statement. So with the logical AND, both sub-expressions have to be true, and with the logical OR, only one of the sub-expressions has to be true. Now we're ready to move on to the next lesson where we talk about how we actually make decisions in C# code using the if statement. And as we go through the ifs, we'll have lots of chances to work more with both the relational operators and the logical operators. Having looked at relational and logical operators, we have the building blocks in place to begin looking at how we make decisions in our C# code. We do that with the if statement. Let me begin by showing you the syntax of the if statement before we look at some examples. And I'll do that in comments up above the program. The if statement begins with if, followed by a relational expression. If the relational expression is true, then the statements that we want to perform or be evaluated are placed right underneath the statement, like so. That's an example of the simplest if you can write. There are more complex versions, but in this lesson we're going to look at just the simplest if. The statements inside the block are only performed if the relational expression is true. So let's look at an example. We'll start out with some variables, and we'll work just with integers here. So we'll have salary and hours worked. Then we might prompt the user to enter their salary, and then a console read line. And then we might prompt the user to enter their hours worked, another console read line. Then we might say if hours worked is less than or equal to 40, let's add another variable here. Gross pay is equal to salary times hours worked. Now notice I didn't put statement block, and I probably should, so let's go back. It actually works without it, but I don't want to introduce that quite yet. So we'll put that back in. Then we can say if hours worked is greater than 40, gross pay is equal to salary times 40 plus salary times 1.5 times hours worked minus 40. The error we're getting is because gross pay could be a floating point number here, so let's just change that real quick. Again, rather than edit out my errors, I'm just going to work through them with you so that you can see how to fix these errors when they crop up in your programs, which they will. Alright, so then we close off this block. And then we can do a console write line. Gross pay is plus gross pay. And then a console read key right here, and yes, I see the error. Okay, here's the problem here. Notice that gross pay is declared but not assigned a value. The values are assigned to it, possibly here and possibly here, but the compiler can't say for sure in which if statement value is going to be assigned. So what we need to do is we need to go ahead and initialize it to a value 0.0, and that clears the error. We didn't get it for salary and hours worked because very clearly we have an assignment statement here and an assignment statement here that don't depend on if statements for their values to be assigned. But when we got to gross pay here, the compiler could not be sure if an assignment was made in this if block or in this if block or at all. So that's why we had the error, and that's why we needed to go back and initialize it when we declared it. Now let's run the program. So we'll do some even numbers. 20, hours worked is 40, gross pay is 800. All right, let's run it again. 20, hours worked is 45, and gross pay is 950. So what happens is, when we entered 40 for the hours worked, then this statement was executed because hours worked less than or equal to 40 is true. When we entered 45, hours worked less than or equal to 40 is false, so it skipped this statement, moved to the next if, and 45 is indeed greater than 40, so this statement was executed, and there we got the gross pay of 950 instead of 800, which we had when the salary was 20 and the hours worked was 40. So those are the basic mechanics of the if statement. There is, however, a better way to write this particular program, using something called an if-else statement, and we're going to look at that in the next lesson. In the last lesson, we looked at using the if statement to make simple decisions. And in the example, we were looking at how to calculate gross pay. And in the example, we had two if statements, one to control if hours worked is less than or equal to 40, and another one if hours worked was greater than 40. Most likely in a real program, we wouldn't write it this way. What we'd do instead is we'd say if hours worked is less than or equal to 40, then gross pay is equal to salary times hours worked, else gross pay is equal to, and then the formula that we used. So let's look at how to write that again using if-else, but first let's look at the syntax for the if-else. And I'm also going to introduce you to a different style for writing if statements. So we start off with if relational expression, just like we did before. And now this time I'm going to put the opening brace for my block on the same line as the if. And then we indent, just like before. And then we write the statement, block, which should be one or more statements. We only had one in this example, but oftentimes we'll have more than one. Then we'll close off the statement block. Then we have the else part. The else part is only to be executed if the relational expression here is false. And again, we indent and then put our statement block inside the else and then close it off with a closing curly brace. The difference between the if-else and the two ifs is that in the two ifs, this if is always evaluated even if this if is true. We only want to evaluate hours worked greater than 40 if it is indeed greater than 40. If hours worked is 40 or less, then all we want to do is execute this statement and then stop calculating gross pay. This part is not even needed. And that's what we get with the else. If the relational expression is true, execute this statement block, else, or otherwise, execute this statement block. Let's rewrite our if statement using the else instead. So the first thing I'm going to do is I'm going to put this opening brace on the same line as the if. Save a little space. We can completely get rid of this. We'll add the else, bring this opening brace here, and now we have the full if-else. Let's execute that, see how it works, make sure that it does work correctly. So we'll type $20 for the salary, 40 hours worked, and that's $800. That's easy to do. Let's run it again. 20, this time 45 hours, and that's $950, so that's right. One thing I want to mention before we leave this lesson is notice the style I use of indenting the statements in the statement block inside the if and the else. That's very important because it makes your program easier to read, and that really should be one of your primary goals of programming. Not only that your program should be executed and that the compiler can execute it correctly and that you get the right outputs given the right inputs, but people are also going to be reading your programs, and so you need to make them as easy as possible to read. And by indenting 2 or 3 spaces or even a full tab, although sometimes tabs can be a problem when you have to indent a lot, but by indenting you make the program easier to read, because if I'm scanning the code and I'm looking for the part that goes inside the if, it's right here. It's easy to find. If everything is left justified in your program like this, and this is certainly legal, it will compile and run, but it's harder to read. Just like we break up sentences into paragraphs, partly for meaning purposes, but also because it's easier to read it and it makes more sense. We do the same thing with indenting code. So even though I tell you that it's not necessary for the compiler that you indent code, but you should still indent it, you need to keep that in mind because these are accepted styles that all programmers follow now. You would never see an experienced programmer write his code all flush left. So this is an example of the if-else. And what I'd like to do in the next lesson is look at some more examples of if-elses where we actually have nested ifs inside ifs. So we'll see that in the next lesson. Take a look at the following mathematical function. It's called the sine function, and it works like this. Sine x, or sine of x, is -1 if x is less than 0. And don't get this confused with the trig function sine. This is completely different. Sine of x is 0 if x is equal to 0, and sine of x is 1 if x is greater than 0. So how can we write this as a C# program? Well, the first thing we could do is write it as a series of if statements. So let's try that. First we'll create a couple of variables, sine and number. Then we'll ask the user to enter a number, and we'll get that number from the console, as we usually do. Now, here's where we have our series of if statements. If number is less than 0, sine is equal to -1. If number is equal to 0, sine is assigned the value 0. And if number is greater than 0, then sine is assigned the value 1. The problem with this code is that, as I said in the last lesson, we really should not code this as a series of independent if statements, because each if will be evaluated regardless of what the value of number is. So even if number is less than 0 and we assign the value -1, we're still going to evaluate number equals 0 and number greater than 0. But what we can do is write it as a series of nested if statements. So let's see how that's going to work. We'll get rid of what we don't need there, and then we'll say else, and then we'll say if number is equal to 0, sign is equal to 0, else sign is equal to +1. Close that else, close that else. Now let's work through the logic before we test the program. I'll tell you what, let's add one more line here. Let's write out the result. Console write sign of number sign. So now let's work through the logic. If the value of number is less than 0, assign the value -1 to sign, and that's all you have to do. If number is not less than 0, then we trigger the else part, and then we say, well, if it's equal to 0, then sign is assign the value 0, and that's all we have to do, and we can stop. Otherwise, else, if number is not less than 0 and number is not equal to 0, well, then it must be greater than 0. We don't need another if test here. We can just go ahead and assign the value 1 to sign and be done with the function. So now let's run it with a couple of examples. So let's try -10, and the sign of -10 is -1. That's correct. Let's run it again with 0, and that's right. Let's try it one more time with a positive number. We'll just enter 1, and the sign of 1 is 1, and that's right. When you're writing nested if statements like this, the thing you need to be careful about is your indentation. Not because the compiler will get it wrong. The compiler never gets it wrong, but because this will keep you from making mistakes. I've spent lots of time correcting other people's code where they wrote everything flush left and had a bug in their program, and all I had to do was get the indentation correct, and then usually the bug discovered itself almost. It was very easy to discover the bug once we got the code into a decent format. So always indent your code inside nested if statements, and other places as well. We'll talk about those later. One technical point I want to make here is that when you're working with nested ifs and elses, remember that an else always goes with the nearest if, so that this else is assigned to this if, or is attached to this if, and this else goes with this if. As long as you remember that, you'll be less likely to make any mistakes when you code nested if statements. Now, having shown you how to write a nested if statement, in most of the cases that you're going to come across, although not all, what you really want is not nested ifs, but something called an if-else if statement. And we're going to look at that in the next lesson, which begins right now. In the last lesson, we saw how to nest an if statement inside another if statement. And often when you do that, what you really want to do is create something called an if-else if statement. So let's take a look at the general syntax for that, then we'll convert the sign program into if-else if. The general format of the if-else if looks like this. If relational expression, and then the statement block, followed by else if and another relational expression, again followed by a statement block, followed by another else if you need it with a relational expression, and this will continue on for as many conditions as you need to test. And then finally, you can end it with an else with a statement block, of course, and then close off the block. So what happens is, as each relational expression is tested, if it's false, you drop down to the next one. Once a relational expression is evaluated true, then you execute the statement block, and then you exit out of the if-else if. This is a much better way to write a nested if statement. It's much more structured, and it's easier for the reader of the program to understand. So let's take a look at how we would rewrite the sign function with an if-else if. So let's just erase the code we had, and then we'll say if number is less than 0, sign equals -1, else if number is equal to 0, sign is equal to 0. And then here we can use another else if, or we can just write an else. We'll just write the else. Sign is equal to 1 and close off the else. -20, the sign is -1. 0, sign is 0. Sign of 20 is 1, and that's right. The if-else-if is much easier to understand. It looks more structured, and you're less likely to make mistakes using that rather than nested if statements. So when you have many related tests to make, and again, these are all related around the value of number being less than, equal to, or greater than 0, then you should use an if-else-if. In the next lesson, we'll look at a more complex example that involves a few more else-if clauses in the if-else-if statement. In this lesson, we're going to look at another example of the if-else-if statement. We're going to take numeric scores and assign them letter grades. We'll prompt the user to enter a numeric grade, and then we'll assign the appropriate letter grade. 90 and above is an A, 80 to 89 is a B, and so on and so forth. So we'll start out first by creating a couple of variables, a grade and a letter grade. Then we're going to prompt the user to enter a numeric grade. Then we'll get that grade from the console. And we'll write if grade is greater than or equal to 90 and grade is less than or equal to 100. We don't necessarily even need that. Letter grade is equal to A. Else if grade is greater than or equal to 80 and grade is less than or equal to 89. Letter grade is equal to B. Before I keep going, let me point out that I'm not using curly braces to delimit the block in this particular example because I only have one statement. When you have one statement, you don't need curly braces around that block. It would be for 2 or more statements. Sometimes you just put them anyway, but I wanted to demonstrate that you can write if-else-ifs without using statement blocks explicitly when it's only going to be one statement. So now we're on to the C grade. Now we're on to D. And then finally, anything else, any other numeric grade will be an F. So then we'll write a little prompt to the user to let them know what the grade is. Now we're ready to test it and see if it works. So let's try a middle C, 75. That's right. Let's run it again. Let's try 99. That letter grade is an A, that's correct. Let's do it one more time. Pull it down where you can see a little bit better. And let's do a 45. Let me scroll up where you can look at it a little bit better. You might notice that the AND part of these relational expressions is not really needed. For example, if I take this out, anything greater than or equal to 90 is going to be an A, so we don't have to put it in the range. And likewise, if I take out this range, and this range, and this, we should get the same effect, so let's give it a try. Let's try 75. That's a C. Let's run it again. Let's try 99. That's an A. Let's do a D this time. 64. This would be the preferable way to write the letter grade program without the ANDs. I was mostly just demonstrating how AND works in a relational expression, but we don't actually need it in this case. The if-else-if should always be used when you have a structured problem like this, where you have several related choices. And with that, we're ready to move to the first exercise in this chapter. For this first exercise in Chapter 8, we're going to play a guessing game. The question is, what was the name of the computer that played on Jeopardy? The correct answer is Watson, and we're going to give the user 3 tries to get the answer right. So we'll start out by storing the answer to the question in a string variable answer, and that's Watson. Then we'll create a variable response that will store the response when the user types it in. Right now it's set to empty string. Then we'll prompt the user And we'll drop to the next line. Name the computer that played Jeopardy. Then we get the response from the user using a console read line, like so. Then we write if response equals answer, and we'll tell that's right, and that's the end. However, if they're wrong, then we'll write console write line, sorry, guess again, prompt the user here, and that actually should be a console write, not a console write line, so let's fix that since it is a prompt. And then we'll write response equals console read line. And then we need another nested if right here to check their response. So we'll write if response equals answer, console write line, that's right. Else, again, if they got it wrong the second time, then we'll write console write, sorry, wrong again, one more guess, response equals console read line. Then our last nested if response equals answer, console write line, that's right, else console write line, wrong again, the answer is Watson. Now what we're left here to do is close out all of these else blocks. So there's one, tab over, and there's the other one. Notice that the editor will fix it up for us to put it in the correct spot. We didn't create a block in this last else, so we don't need anything there. Everything else looks lined up, and this is why we use indentation, is to make sure that we have everything properly closed. By indenting, we can see where a closing brace needs to go. So we need one here, and we need one up here. Now let's test the program and see if it works. We have a write line here. We'll fix that in a moment. Name the computer that played Jeopardy. Let's get it right the first time to see. Okay, so that works. Let's run it again. Let's just type some response. Ed, that's wrong. So we'll try Watson on the second guess, and we got it right. Now before we go on, let's fix this prompt right here. Change that to a write. Now let's try it again. There we go, I like that better. This time we'll say Deep Blue. Sorry, guess again. Let's say ENIAC. Sorry, wrong again, one more guess.